Start.
Good morning, students. Today we will start our experiment 4. Please write the heading of experiment 4, determination of alkalinity of water by acid base titration. In our previous class, we have already done one acid base titration, which was oxalic acid versus sodium hydroxide. But to don't experience the hand-to-hand practical, particularly we have done this theoretically by giving some pre-assumed data, and then you have calculated the concentration of the NaOH. But today we will do our experimental section for our experiment 4, determination of the alkalinity of water. Hope you don't know about this term alkalinity. This is very important term for water quality analysis, that water is alkaline due to presence of these anions. Water is alkaline due to presence of these anions. Actually, there are huge course of theory behind this experiment, but I will not go through the details of this experiment. I will just go through the experimental section specifically for alkalinity of water. Now, due to presence of three anions, OH minus, carbonate and bicarbonate, water become alkaline. Okay. Now we need to find that which anions are actually present and what is the amount of that anions present in water. Okay. Now I have done in experiment 3, I have done neutralization reaction, that was H plus OH minus from there H2O. It was neutralization reaction. I have already told you in experiment 3 that acid means pH 0 to 7, base means pH 7 to 14, and neutral means pH equals to 7. So when acid base react together for the formation of water, that means the process is known as neutralization. So there will be no acid, no base, but it will give us the neutral pH, which is pH 7. Now if water contain these three anions, OH minus, carbonate and bicarbonate, then if we apply neutralization process to neutralize this anion, then we have to add H plus. That means whatever may be the concentration or amount of OH minus, carbonate and bicarbonate present in water, if you add H plus, then all of these anions go for neutralization reaction. That means all of these anions will form salt and water. Okay, obviously OH minus solely not be present in water, maybe in the formation of KOH, maybe in the formation of NaOH, maybe carbonate will be present in water in the formation of sodium carbonate, potassium carbonate, iron carbonate, maybe bicarbonate will be present in as calcium bicarbonate, sodium bicarbonate, potassium bicarbonate. So we are excluding cations, we are only taking anions for the experiment. So due to presence of these three anions, water become alkaline. Now if we want to remove this alkalinity, to calculate the amount of OH minus or carbonate or bicarbonate present in water, we need to add H plus. H plus will react all of these three components for the formation of salt and water. That means H plus will neutralize these anions. Now water never contain these three anions in a row. একসাথে এই তিনটে anion থাকবে। Okay, but there may be some combination. First we will try the neutralization process. If OH minus react with H plus, then it will form H2. If carbonate react with H plus, at first step it will convert it into HCO3 minus, and in second step it will convert it into H2CO3 or H2O plus CO2. For bicarbonate, it will trap H plus for the formation of H2O plus CO2. Okay, so So these are the neutralization reaction. Out of these three neutralization reaction, first case OH minus only taking 1 H plus for the formation of H2, but for carbonate is taking 1 H plus for the formation of bicarbonate, and in next step is taking another H plus for the formation of neutral components. For bicarbonate is taking only 1 H plus for the formation of neutral component. Now let us come to the experimental section. Let us say in one conical we have taken some amount of water. Okay, and let us assume that water contain these anions, maybe OH minus, maybe carbonate, or maybe bicarbonate. Hote pare water contain OH minus, maybe water contain bicarbonate, or maybe water contain carbonate, or maybe water contain bicarbonate. So we will conclude this thing after completion of experiment. How? Let us take some amount of water in conical. If water contain any of these three anions, start addition of acid. Acid means we are actually adding H plus. For today's experiment, we will use H2SO4. Okay. For today's experiment, we will use H2SO4. Now, if you add H plus in water solution, obviously this neutralization reaction will start. If it contains OH minus, then it will be converted into H2O. If it contains carbonate, it will be converted into bicarbonate, then H2CO3. If it contains bicarbonate, then directly it will be converted into H2O plus CO. So, how to detect that after addition of H plus, water become neutralized? How to detect? We have already done in case of our experiment 3, acid-base titration, that to detect neutralization process, we need to add some indicators. Okay, if you add indicators, indicator will show you the color at the neutralization point. Here also we will use some indicator, but before that I will make sure that we will find the combination of these three anions. How? Let us say water may contain OH minus, water may contain carbonate, water may contain bicarbonate, or water may contain combination of these two, OH plus carbonate or carbonate plus bicarbonate. Water may contain combination of these two. Now we will check before experiment in theoretical portion that which anions may be present there. Look here. Initially we have taken some amount of H2O in conical flask. Okay. If water is alkaline, then add some indicators. Initially we will use phenolphthalein indicator. Okay. Phenolphthalein only show its color for OH minus and a part for bicarbonate. Carbonate. So phenolphthalein only show its color. It actually depends on pH. I am not going through that details. So if you add phenolphthalein, if water contain OH minus, your color will be pink because OH minus is basic medium. So if you add phenolphthalein, if your water color will be pink, then water may contain OH minus or may contain carbonate. We can't conclude. Okay. Now after addition of phenolphthalein, your water is become pink. Then start addition of H plus. That means H2SO4. We have started addition of H2SO4 or H plus. So if water contain OH minus or carbonate, obviously neutralization reaction takes place. Let us say after a certain time of addition, water become colorless. Pink color become colorless. That means water become neutralized. Okay. Now you take volume from burette. We have added H plus from burette. Take the volume from burette. From burette reading, we can conclude that amount of H plus actually responsible for the neutralization of OH minus or carbonate. Okay. Now let us say if after addition of V1 ml of acid, your water become colorless. That means after addition of V1 ml of acid, your total neutralization process in presence of phenolphthalein done. Okay. So that V1 may be responsible for the total neutralization of OH minus, or you know that after taking one H plus, carbonate converted into bicarbonate. Okay. So total neutralization of OH minus or half neutralization of carbonate. So V1 is responsible for the total neutralization of OH minus or half neutralization of carbonate. Because once it is converted into bicarbonate, phenolphthalein can show its color for bicarbonate. Due to some pH issues, I am not going to phenolphthalein can't show its color for bicarbonate. It will only show its color for OH minus and carbonate. So if your solution turns pink, you have added some amount of H2SO4 from burette and that volume is V1. That means V1 ml of H2SO4 responsible for the total neutralization of OH minus or half neutralization of carbonate. Okay. Now don't throw this solution. Your solution is colorless now. In that solution you add another indicator, methyl orange. Okay, methyl orange can show its color for bicarbonate. Methyl orange can show its color for bicarbonate. Now if your solution contains some amount of bicarbonate, then that indicator will turn yellow color. Okay, if your solution contains some bicarbonate, your indicator turns yellow color. Now what is the source of bicarbonate? Water may contain bicarbonate, or maybe after addition of acid, carbonate converted into bicarbonate. So that bicarbonate will be responsible for the showing of color of the methyl orange. Okay. So two possibilities: water may contain bicarbonate salts directly, or some carbonate salt converted into bicarbonate after addition of V1 ml of acid. So two possibilities are there. Let us do the titration process. You add acid from burette and your yellow color turns light pink at neutralization point. So let us say we have added, second case we have added V2 ml of acid. Okay. So for first case, that means when we have added phenolphthalein indicator, we have added V1 ml of acid for neutralization, and for methyl orange indicator we have added V2 ml of acid for neutralization. Now we will conclude. We will conclude how? You know that V1 ml of acid responsible for the neutralization of OH minus or half neutralization of carbonate. V1 ml of acid is responsible for full neutralization of OH minus or half neutralization of carbonate, whereas V2 ml of acid responsible for the full neutralization of bicarbonate or neutralization of the converted bicarbonate. Okay. Now let us say your V1 equals to 0. That means when you have added phenolphthalein, there will be no color change. Then what happens? যখন initially আমি phenolphthalein add করছি তখন যদি there will be no color change, that means my solution doesn't contain any type of OH minus or carbonate. So if your value of V1 is 0, then there will be no OH, no carbonate. That means there will be only bicarbonate. It is possibility number 1. Okay. When V2 equals to 0, that means when you have added methyl orange, there will be no color change. Methyl orange only show color for bicarbonate. So when V2 equals to 0, that means there is no bicarbonate. It only contain OH minus. So it will be possibility number 2. If V1 equals to V2, then V1 equals to V2 means when you have added V1, then carbonate converted into bicarbonate, and then added V2, again 1H plus, bicarbonate converted into H2 plus CO2. That means when V1 equals to V2, your solution contain only carbonate. That is possibility number 3. When V1 greater than V2, when V1 greater than V2, that means your solution contains OH plus carbonate. OH plus carbonate. Okay, that is possibility number 4. When V2 greater than V1, it is actually means your solution contains carbonate and bicarbonate. Because when you have added V1 ml of acid, carbonate is half neutralized, and after addition of V2 ml of acid, the carbonate and the converted bicarbonate is fully neutralized. So in that case, V2 will be greater than V1. It will be possibility number 5. So there are 5 possibilities, and we can check that which set of alkaline substance present in water after completion of process, not before that. Okay. So now we will go through the process. Now we will Now we will start our experimental section. As H2SO4 will be used as neutralizing acid. So first we will go for the standardization of H2SO4. As we all know that H2SO4 is secondary standard, and we don't know the actual concentration of H2SO4. So first we will fill butyrate with H2SO4. Okay. I have already shown you that once you fill solution in butyrate, first you rinse butyrate by the same solution. So I have rinsed the butyrate by H2SO4. Then I fill butyrate by H2SO4 solution, make it air free, and then volume makeup up to 0. Okay. Then we fix that butyrate in butyrate stand. Okay. Now to standardize H2SO4, we need to take one primary standard base. So here we have the choice of sodium carbonate, which is written N by 10. We will standardize H2SO4 by N by 10 sodium carbonate. Okay, N by 10 sodium carbonate. Sodium carbonate is primary standard. That means we know the concentration of sodium carbonate. It was previously made and concentration remained constant throughout the time. So it is N by 10 sodium carbonate. Now according to the process, initially we will take 10 ml of sodium carbonate via pipette. Here it is sodium carbonate. We have pipetted out 10 ml sodium carbonate. Now for this acid base titration, the suitable indicator is methyl orange. So we will add 1 drop of methyl orange. Okay. We will add 1 drop of methyl orange. After addition, the solution turns yellow. Asse sir, color. The solution turns yellow. Now we start addition of H2SO4 from butyrate. Okay. So it will be more better to check the color change, that we place one whitish coffee or whitish paper below conical glass. Okay. So my solution color is now yellow. Now I have started addition of H2SO4 dropwise. Okay. I have started addition of H2SO4 dropwise. Once it will turn into pink color, stop addition. Added. I am continuing addition. Very cautiously, dropwise, one drop. You maintain the acceleration of the falling of drops. Very cautiously, one drop. Now it turns pink. Look here. Look at the color difference. When I have started, it was yellow. Now it turns pink. Now I will check the volume. I will check the volume from burette. Look here. It is exactly at 1 to 5. It exactly as at 5.9. So my first reading is 5.9. Okay. As you know that we need to repeat the titration process. So we will show the solution in basin. We will wash the conical flask again, and again we will repeat the process. To get the exact reading, we will repeat the process. Take 10 ml of sodium carbonate. Then I have 1 drop of methyl orange indicator. It will turn yellow. Now we will start the same process of neutralization. We need to shake conical flask so that the solution will become homogeneous. Okay. Now hope done. Look at the color change, turns pink. Okay. Now again we will check the volume. Sir, এখানে একটু দেখান তো এটা is exactly 11.8. So both readings are 5.9. Okay. So both readings are 5.9. So all of you know that for every titration process we need to draw one titration table. Here also first reading H2SO4 versus sodium carbonate is the heading, and what is the process heading? It is actually standardization of H2SO4 by sodium carbonate. This is the process standardization of H2SO4 by sodium carbonate. So when you need to draw the titration table, look here. You already know that first you need to put the known data. So at very end, I am writing number of observations. We have taken 2 observations. Now volume of Na2CO3, I have taken 10 ml both, and now strength of Na2CO3, I have shown you that it was written n by 10, and now burette reading. I have started with, so it will be initial, then final, then difference, and then average. I have started with 0. Final reading was 5.9, so difference is 5.9. From second reading I have started from 5.9. My final reading is 11.8. It is also 5.9. Average also 5.9. So 5.9 ml H2SO4 required to standardize sodium carbonate. Now apply V1H1 V2H2 rule as I have shown you. V1 into S1 equals to V2 into S2. What is V1? V1 is 10 ml. What is S1? S1 is n by 10. What is V2? V2 is 5.9. And then we will calculate S2. S2 will be n by 5.9. That means concentration of H2SO4 equals to n by 5.9. এটাকে বক্স করে লিখে দাও। So strength of H2SO4 measured is n by 5.9. Okay, now what we will do, we will pipette out tap water to calculate the total alkalinity of water. Now this is our main task, that to calculate total alkalinity of water. We have taken 10 ml initially. We need to take 20 ml water, otherwise it is very difficult to check the color changes. Okay, so first 10 ml and then again 10 ml. Okay, so this is 20 ml water. According to theory, according to theory, initially we add phenolphthalein indicator. If OH or carbonate may be present in water, then phenolphthalein it's show its pink color. Okay, so initially we will add phenolphthalein 3 to 5 drops. Okay, we have added phenolphthalein. Now shake the conical flask well. You just remember that if OH may be present, carbonate may be present, it contains very low amount. If OH may be present, then it also very low amount. If carbonate may be present, also low amount. So we need to shake well to get the pink color of phenolphthalein. Hope now it is slightly pink. You can check. True, it is slightly pink now. Sir, বোঝা যাচ্ছে? কালারটা ফেড হয়ে যাচ্ছে। ওয়েট লাইট অন করি।